Welcome to Program 102B on the IBM Selectric Typewriter. This program covers manipulative skills and procedures dealing with the negative power section of the Selectric Typewriter. By the end of this program, you will have learned how to install the carrier return and escapement cords, or cables, and how to reinstall and adjust the escapement bracket, as well as all of the mechanisms affected by the removal of the escapement bracket. The materials you need for this segment include the standard toolkit for office machine servicemen, the special tools used for Selectric typewriters, the Selectric typewriter itself, and the IBM Selectric Adjustment and Parts Manual, Form number 200 415939. The use of the Selectric Service Manual is also recommended. The Adjustment Manual and the Service Manual are copyrighted property of IBM Corporation, and the use of some of their drawings in this program was made possible through the courtesy of IBM's management. The photographs, recordings, and all supplementary materials are copyrighted property of Audiovisuals Universal Incorporated, Los Angeles, 1978. In addition to the program on fundamentals of mechanics, the essential prerequisites for this program are the successful completion of learning programs 10.1a, 10.1b, and 10.2a of this series of Selectric technical training programs. Theory discussions have deliberately been de-emphasized in this particular program. We will use a single pitch machine with a 13-inch platen for this presentation. You may find small variations in the procedures or the parts if your machine is not the same model. Let's develop an overview of the task ahead. We know that positive power, or motor power, in the Selectric typewriter is made available through the operational shaft. Through a number of clutches, such as the carrier return clutch, the pinion of which is indicated by the green pencil, the operator can use this positive power to drive any of a number of output mechanisms, which then accomplish what she wishes the typewriter to do. When we operate the carrier return clutch, we cause the escapement shaft, yellow pencil, to turn top to the right, using the power of the motor. In doing so, we load the mainspring located at the rear end of the escapement shaft. We have learned to refer to the energy stored in the mainspring as negative power. The action of the carrier return mechanism restores the mainspring tension and thus replenishes the source of negative power. Here is a listing of the functions of the various mechanisms that affect negative power. The mechanisms that use negative power are the printing escapement, the spacebar escapement, and the tabulation mechanism. The restoring of negative power is accomplished through the backspace mechanism, the express backspace mechanism on Selectric II typewriters, and the carrier return mechanism. First, we will disassemble some of these mechanisms, and then, as we learn how to reassemble them, we will perform the various adjustments. At this point, remove the platen and the right front feed roller from your typewriter if it is a 13-inch or 15-inch plat machine. Remove the front feed roller if your machine has an 11-inch platen. After every assignment like this one, pause the video and carry out the assignment, then continue when you have finished. Before we move on, let's clear all of the tabulation stops. First, let the carrier move all the way to the extreme right side of the machine, and then move the left margin stop all the way to the left. Hold the Tab Clear key down while depressing the carrier return key, allowing the carrier to return all the way to its extreme left position. Now unplug the machine. With the carrier all the way to the left side of the machine, disconnect the escapement cord from the anchor spot on the carrier. Notice the way the cord is connected to the carrier. The knot, so to speak, is placed toward the rear of the machine. The forked end of the IBM string hook is by far the most practical tool for this job. If you have one, use it in the manner shown. You will find that the only tension on the cord is that of the tension pulley spring on the right side of the machine, at least as long as you do not turn the hand cycle knob. And by the way, do not turn the hand cycle wheel yet after you have disconnected the escapement cord, because otherwise you might tangle up the carrier return cord. Now disconnect the escapement cord from the escapement cord drum at the indicated point. Again, make sure to observe how the cord is connected before you disconnect it. Pull the escapement cord out of the machine entirely and lay it aside for the time being, preferably somewhere it will not pick up unnecessary dirt or grease. Any of these tabulation or escapement cords, made of nylon, can easily be cleaned with plain soap and water or any other household cleaner. When you work on any machine, there is never an excuse to leave it with dirty escapement and carrier return cords. Now depress the Tab key, and then, with one hand, pull the carrier toward the right while with the other you turn the hand cycle knob until the carrier comes toward the center of the machine. Can you tell why the carrier can move toward the right only when you also turn the hand cycle wheel? Your answer should have been, because of the action of the Tab governor clutch. The carrier can only move toward the right and pull on the carrier return cord if the Tab governor clutch pinion is allowed to rotate top toward the front as well. Because of the indicated clutch spring, this is possible only if the operational shaft is also allowed to turn top toward the front. Continue to pull the carrier toward the right while hand turning the cycle knob until the carrier is positioned over the carrier return clutch. Remove the indicated idler wheel, or pulley, to avoid having it fall out of the machine at an inopportune time. From underneath the machine, find the anchor spot for the carrier return cord, and then disconnect the indicated lug from it so you can remove this end of the cord from the top of the machine. Then pull the carrier return cord out toward the rear of the machine, and also remove the carrier return cord idler pulley. Now pull on the carrier return cord while rotating the hand cycle wheel top toward the front, until the end of the cord and its hookup point on the carrier return cord drum appear in the position shown here. It will then be easy to disengage the cord from the drum and remove the carrier return cord from the machine. Once again, observe how the cord is fastened onto the drum so that you will have an easier time reconnecting it. If you said the Tab governor clutch, you nailed it. Its pinion can only rotate top toward the front when the operational shaft turns with it, so pulling the carrier right without turning the hand cycle wheel gets you nowhere. If we now rotate the hand cycle wheel top to the front, we find that the indicated escapement cord drum continues to rotate top to the left. This happens because the force of the mainspring is being released every time we turn the operational shaft top toward the front. For now, do not turn the hand cycle wheel by more than 4 turns, otherwise the mainspring may come off the machine. After we depress the carrier return key, however, the indicated drum will rotate top to the left by the action of the carrier return clutch. As long as this happens, the mainspring will be tightening or accumulating tension. The carrier return clutch will continue to load the spring until the spring is completely loaded, at which point the escapement drum can no longer turn top to the right. At this point, the torque limiter clutch will begin to slip. Now we can find out the maximum number of turns we can load onto the mainspring. After you have brought the torque limiter clutch to the slipping point, use as a reference point either the escapement cord anchor point indicated in the frame on the left, or the inside end of the mainspring indicated in the frame on the right. Depressing the Tab key will disengage the carrier return mechanism if your machine is equipped with a carrier return override clip, indicated in the lower right-hand frame. If your machine does not have that feature, you will have to disengage the carrier return mechanism manually by disengaging the latch from the keeper at the point indicated by the green pencil in the main picture. After you have disengaged the carrier return mechanism, turn the hand cycle wheel while counting the number of turns of the escapement shaft, until the escapement shaft no longer turns, at which point all the mainspring tension has been released. If your machine is equipped with a long-eared mainspring housing, you should have counted approximately 12.5 turns of the escapement shaft. On the short-eared mainspring housing, you should have found that 13.5 turns are necessary to completely relieve the mainspring tension. From this, we learn that it is possible to load the mainspring tension using the carrier return mechanism, and that the springs encountered on Selectric typewriters come in 2 different lengths. We saw in the previous program that the mainspring tension should be adjusted so that it exerts a pressure of approximately 1/4 kilogram, or 3/4 pound, on the carrier when the carrier is in its extreme right position. This condition is obtained by engaging the center of the mainspring with the hub at the rear extremity of the escapement shaft, and then manually turning the mainspring housing before reconnecting it to the machine. For mainsprings with a long-eared housing, we need 5 turns of the mainspring with the carrier at its extreme right position. For springs with a short-eared housing, we need to turn the housing 7 turns. If your machine has the on-off switch positioned to the rear of the mainspring, you will need to temporarily remove the switch from its mounting bracket, and to do this, it is also necessary to disconnect the indicated link from the toggle arm. Once you have done this, remove the mainspring from the escapement shaft. Notice that this mainspring hub is made of nylon. Occasionally, this kind of hub will crack. If this happens on a machine you're working on, be advised that IBM manufactures a metal hub for the mainspring, indicated by the yellow pencil. This hub can simply be placed on the escapement shaft that had the broken nylon hub. The part number for this hub is 1,140,1300, and it is, of course, listed in the parts book. Now tilt the machine onto its back and loosen both of the screws that hold the carrier return drum to the escapement shaft. Always be careful with the amount of torque you apply to these screws. Since the hub of the carrier return drum is made of aluminum, it is very easy to strip the threads. Then loosen the indicated set screw for the escapement, or tabulation, cord drum. Afterwards, you should be able to remove the escapement shaft from the rear of the machine, and as a result, extract the escapement cord drum and the carrier return cord drum. If you run into any difficulty as a result of screw burrs on the escapement shaft, be gentle and moderate in the force you apply to overcome the resistance. Be extra careful not to damage any parts. Make sure the set screws are backed out far enough, and then try to use only your bare hands to remove the escapement shaft. On some machines, you will find a spring between the carrier return drum and the front bearing for the escapement shaft. This spring serves to make reassembly of the mechanism easier. The way we will show you how to reassemble the mechanism does not require your machine to have this spring. You should, however, reinstall the spring anyway, if for no other reason than to make things easier for the next person who might have to work on the machine. Disconnect the restoring spring for the ribbon lift control link at the point where it is fastened to the escapement bracket. Depress the tab key so that the carrier is free to move, and make sure that all tab stops are still reset or cleared. Then, once again, move the carrier until it stops over the carrier return clutch, as shown in the picture on the right. At this point, remove all the indicated screws which hold the escapement bracket to the carrier frame. Of course, the card holder and the tab set and clear plate will also come off in the process. Next, disconnect the tabulation torque bar link at the point indicated. The best tool for the job is the IBM spring hook, used as shown. Then remove the indicated carrier return override clip from the tabulation torque bar so that we can slide the torque bar toward the right of the machine. Keep a finger on the clip as you remove it. Otherwise, it is liable to fly off in any direction as soon as it comes off the torque bar. With the carrier positioned over the carrier return clutch and the escapement bracket loose, you should be able to bring the left end of the tab torque bar slightly toward the front and upward. So the torque bar can be guided through the rotate arm hole in the side frame and come out of engagement with the indicated torque bar support bracket on the right side of the machine. As a result, you will be able to position the tabulation torque bar over the top edge of the left side frame, as shown by the red pencil. Before we continue, push the ribbon load lever indicated by the yellow pencil toward the right, which lifts the ribbon guides. We are now able to lift the right side of the escapement bracket high enough to let us move the carrier toward the right while leaving the escapement bracket behind. Be extra careful not to force anything while moving the indicated detent control arm pivot point past the right arm of the escapement bracket. Nothing, absolutely nothing, in this operation requires forcing parts. Whenever you detect any obstacle, pinpoint it first, remove it, and then proceed with moving the carrier completely away from the escapement bracket. We could just as well move the carrier toward the left of the machine, leaving the escapement bracket behind, provided that before moving it, we remove the indicated velocity control cable guide. However, at some point in this process, we must move the carrier to the right in order to remove the tab torque bar from the left side of the machine. To further ease removal of the escapement bracket, you may remove the low-velocity control cable guide from your machine at this point, although this step is not absolutely necessary. Then move the carrier away from the escapement bracket. This lets us very comfortably remove the escapement bracket, together with the tabulation torque bar, from the machine. Once again, nothing in this process requires the use of force. Start with a slight upward action before you attempt to remove the escapement bracket. Use moderation and keep your thoughts on the tiny springs of the escapement mechanism. Whenever we remove the escapement bracket from the machine, we must immediately examine the condition of the indicated springs. They are rather delicate, and if they are damaged in any way, the escapement mechanism may develop intermittent failures. Now is the time to examine some of the finer points of the operational theory of the escapement. Points such as the tab lever lug, indicated by the yellow pencil, and its action upon the escapement pawl, are somewhat hard to see from underneath the machine compared with how easy they are to examine when you have the parts in your hand. Do you still remember why the tab lever lug only grabs the small edge of the step in the escapement pawl? And while you're at it, what is the purpose of the lug indicated by the red pencil? Here are the answers. The tab lever lug, yellow pencil, holds the escapement pawl out of engagement with the escapement rack during tab operations. It uses only the small edge of the step in the escapement pawl because, as soon as the tab lever stops moving after encountering a tab stop, the escapement pawl can immediately be re-engaged while the carrier still continues to move rightward. Eventually, the escapement pawl will, of course, stop the carrier. The step in the escapement pawl is needed to allow for prompt escapement pawl re-engagement at the end of tab operations. The purpose of the lug indicated by the red pencil is to provide an overthrow stop for the tab lever during tabulation engagement. The lug stops against the front surface of the tab lever latch whenever the tab lever tends to be thrown too far toward the rear. Among the absolute musts of reinstalling the escapement mechanism of the Selectric typewriter is a close examination of the indicated tip of the escapement pawl, and also of the backspace pawl, for possible wear. In both cases, replacement of the pawls is the best solution whenever there are signs of wear. Two of the most unforgiving giveaways of poorly made adjustments are the indicated torque bar backup dimples in the escapement bracket. Early escapement brackets have only one dimple. These dimples are meant only to serve as backup stops for the tabulation torque bar. They are not meant to rub on the torque bar while the carrier moves. Notice the groove indicated by the yellow pencil. It was cut into the dimple as a result of maladjustment of the escapement bracket and/or the tab torque bar. The fact that this sample shows wear only on the left side dimple, positioned on the right side here because we are viewing the escapement mechanism from the rear, indicates that the escapement bracket was not parallel to the tab torque bar before we removed it from the machine. When these signs of wear are found in a machine, it is not necessary to replace the escapement bracket outright, because it is possible to compensate for this wear through adjustments. At this point, we suggest that you review, as thoroughly as you can, the theory of operation and adjustments of the negative power section of the IBM Selectric typewriter, using the parts you have removed from the machine. If you have any difficulty organizing your thoughts in this review, we suggest running through program number 10, 2A one more time, this time without carrying out any of its assignments, and this time with all of the components of the negative power section in your hand. One of the parts of the negative power section of the machine is missing in this picture. Which one is it? Your answer should have been the tab set and tab clear plate. Before we start reassembly, if you wish to conduct further exploratory disassembly of the escapement mechanism, perhaps to become better acquainted with its parts, feel free to do so at this time. These views of the escapement bracket are meant to guide you during reassembly. On the left, we have a top-rear view of the escapement bracket, and on the right, a bottom view with all of the components in their places. If you remembered that it's all about a quick re-engagement, well done. The lug holds the pawl out of the rack during tabs, but by righting only the small edge of the step, the pawl can snap back into the rack the instant the tab lever stops at a tab stop, while the carrier is still moving, so the pawl can bring the carrier to a halt. If you set an overthrow stop for the tab lever, exactly right. When the tab lever tends to be thrown too far toward the rear during tab engagement, that lug stops against the front surface of the tab lever latch and keeps things in bounds. If you spotted that the tab set and tab clear plate is missing, sharp eyes, that plate came off along with the escapement bracket, and it belongs right there with the rest of the negative power components. Let us begin the reassembly and adjustment sequence. All that really needs to be done here is to reverse the sequence of disassembly. So we start by first introducing the escapement bracket and the tabulation torque bar into position, and then pushing the carrier back under the escapement bracket. Once the escapement bracket is properly situated over the carrier, or rather, once the carrier is back under the escapement bracket, reinstall the tab torque bar. First on the right side, into the tab torque bar support bracket, shown in the lower right-hand corner, and then into the left side frame, shown in the main picture. Then reinstall the carrier return override clip so that there is only a small lateral play for the tab torque bar. There should not be any bind for the rotation of the torque bar. The indicated lug on the clip must be positioned flush with the rear surface of the tab torque bar. Now reconnect the tabulation torque bar link. For the time being, we need not worry about the exact angular position of the tabulation torque bar, because its adjustment will depend in part on the position of the escapement bracket. Now reinstall all 4 escapement bracket hold-down screws, but barely tighten only 2 of them. The clearance at the indicated points between the escapement bracket dimples or dimple and the torque bar should be approximately 1/4 of 1 millimeter. After you have installed the escapement bracket, move the carrier across the full width of the machine and make sure the escapement bracket does not rub against the torque bar. Do not hesitate to increase the clearance in order to avoid friction between the 2 parts. We must first adjust the position of the torque bars before we can finalize the positioning of the escapement bracket. This is the list of sequentially organized escapement adjustments. Whenever any one of these adjustments is made, all the adjustments that come after it have to be checked because they could have been affected and may need readjusting. Notice that adjustment number 3 calls for the parallelism of the tab torque bar, which is part of the tabulation mechanism and not the escapement mechanism. The reason is that we need the correct position of the tabulation torque bar to use it as a reference point, a fixed point, for adjusting the position of the escapement bracket. This means that in actuality, we have only 6 basic adjustments for the escapement mechanism. As we saw earlier when we studied the theory of operation of the printing escapement and spacebar escapement, once the escapement torque bar has been positioned angularly, the remaining escapement adjustments start at the spacebar escapement selector latch and the printing escapement cam on the filter shaft. The adjustments of those sections of the negative power were not disturbed during our disassembly work, so they will not be discussed in this program. You are expected to carry out any adjustment your machine might need at the conclusion of the program. For your orientation, the spacebar escapement adjustments start with the rest position of the spacebar selector latch and end with a gap, or clearance, between the right end lug on the escapement torque bar and the escapement trigger. The printing escapement mechanism starts with the cam on the filter shaft and converges to the same spot, namely, the clearance between the escapement trigger and the right end lug on the escapement torque bar. The 2 mechanisms must not interfere with each other at any time, and must not present any loss of motion beyond the 0.25 millimeters needed to close the gap between the trigger and the escapement torque bar lug. We suggest that you review these adjustments on your own if the last 2 slides raised any questions for you. As mentioned, you will find the material covered in program number 10.2a. If, after reinstalling the escapement bracket, you attempt to move the carrier with the newly installed bracket, be prepared to encounter obstructions from tab stops that were rotated too far top to the rear during the manipulation of the escapement bracket. They must be returned to their normal rest position with the aid of a screwdriver, as shown, before the carrier can move freely. The fundamental adjustment of the escapement mechanism is the positioning of the escapement rack. The distance from the front edge of the escapement rack to the front edge of the filter shaft should be equal to 6.2 centimeters. These 6.2 centimeters represent the distance from the number 1 scribe line setting of the hooverometer to the inside edge of the L-shaped portion of the hooverometer. The escapement rack hold-down screws, one of which is indicated, fit into rather wide openings in the escapement rack, making it possible to shift the position of the rack. Quite naturally, this measurement must be performed at both ends of the escapement rack and, just to be sure, once in the center of the rack. The clearance between the escapement torque bar backup stud and the torque bar should be minimum, with the stud in the leftmost position for single pitch machines and in the rightmost position for dual pitch machines. This adjustment, however, can only be performed after the position of the escapement bracket has been permanently established. In the first secondary adjustment of the escapement mechanism, we will use the temporary position of the escapement torque bar backup stud as a reference point. To adjust the parallelism of the escapement torque bar, first create a gap between the torque bar and the backup stud, and then move the carrier across the full width of the machine to check for any change in the size of the gap. We change the position of the stud by loosening the nut indicated by the yellow pencil, and then applying a screwdriver to the bottom of the backup stud indicated by the red pencil. The parallelism of the escapement torque bar can be altered by first loosening the screws indicated by the yellow pencil and by the screwdriver, and then rotating the torque bar support bracket on the right side of the machine, top to the front or top to the rear, depending on the alignment needs. The bracket pivots around the pin located underneath the small arrow painted directly onto the support bracket. Of course, the bracket can also be rotated top to the rear, against the direction of the little arrow. But regardless of which way we need to turn it, we must first move the tab rack support bracket out of the way, because at the point indicated by the red pencil, this bracket would prevent any movement of the torque bar support bracket. In fact, some older machines have no provision for adjusting the parallelism of the torque bars because 2 pins lock the torque bar support bracket to the power frame. At times, it is necessary to remove one of the pins in order to correct the adjustment. At this point, make the necessary adjustments on your machine until the escapement torque bar is absolutely parallel to the print shaft. This constitutes the first secondary adjustment of the adjustment sequence for the escapement mechanism. One most important point about the reference point indicated by the red pencil. Only on machines equipped with a separate support bracket for the tab rack, such as this one, can the tab rack be adjusted so as to become truly parallel to the print shaft. We shall touch on this subject again later in this program. For the adjustment of the parallelism of the tab torque bar, we use the same technique. First, we temporarily position the escapement bracket so that we have an easily detectable clearance between the tab torque bar and the escapement bracket. Then, we move the carrier across the full width of the machine while observing any possible changes in the dimension of the gap. If the parallelism of the tab torque bar needs adjusting after the escapement torque bar parallelism has already been adjusted, we must resort to forming the indicated tab torque bar support arm on the right side of the machine. Just as with the escapement torque bar, only the right side of the tab torque bar can be changed. The left side pivot point is a hole in the side frame. Whenever forming of the indicated support arm is necessary, it is best to anchor down the escapement torque bar support bracket as well as possible so that it does not inadvertently shift while we form the indicated arm. At this point, check the tab torque bar parallelism of your machine and make any corrections it might need. This constitutes the second secondary adjustment in this sequence. Unfortunately, we cannot totally separate these adjustments from each other. In fact, after the position of the tab torque bar has been changed, it is also necessary to readjust the parallelism of the escapement bracket to the tab torque bar. Furthermore, whenever we change the position of the bracket, we must also readjust the position of the escapement torque bar backup stud. What matters is that eventually there should be zero friction and minimum play between the various parts. The carrier must be absolutely free to move left and right. Now we can finalize the adjustment of the escapement bracket position. Depending on the model of machine you are working with, use the corresponding specifications given in the lower half of this frame. For our sample machine, the specifications in the center apply. When you are done, tighten down all 4 hold-down screws for the bracket. We shall leave the installation of the card holder for last, when the machine prints again. This constitutes secondary adjustment number 3, or the 4th step in our adjustment sequence for the escapement bracket. Notice the remark in the lower left-hand corner of the adjustment frame. The information that the tab adjustments have to be made after the positioning of the escapement bracket is insufficient. The escapement torque bar backup stud adjustment is definitely another adjustment which must be made after the positioning of the bracket. It often happens that once the escapement bracket has been properly positioned, the escapement torque bar backup stud is pushing quite hard against the escapement torque bar. It is therefore necessary, immediately upon conclusion of the escapement bracket adjustment, to readjust the position of the escapement torque bar backup stud. We should not attempt to move the carrier back and forth before this step has been taken care of. Secondary adjustment number 4, the 5th step in our sequence, is the escapement torque bar backup adjustment. As mentioned earlier, our example machine requires the specification represented graphically in the upper left-hand corner of this frame. The clearance of 0.03 of 1 mm is impractical to measure. If you leave your backup stud just touching the escapement torque bar, consider this okay. Be careful, however, not to let the backup stud turn with the nut while you tighten the nut. Check your adjustment one more time after you have permanently fastened the nut. One more note before we move on. Early machines also came equipped with a backup lug fastened to the power frame and positioned to the rear of the torque bar. If your machine has one of these, and if it barely touches the torque bar, consider the adjustment okay. No matter which level your machine is, the clearance between the escapement torque bar and the vertical lug of the escapement pawl should be 1/4 of 1 mm, as depicted in the circular inserts of this adjustment frame. Again, check your machine for these specifications and adjust the angular position of the torque bar accordingly. This is the 5th secondary adjustment of the escapement mechanism, and the last adjustment of the system in the direction from the escapement rack to the escapement trigger gap. As explained earlier, the other side of the escapement trigger gap now has to be adjusted, and those adjustments start at the selector latch and at the escapement cam on the filter shaft. We strongly recommend at this point that you go over and complete the adjustments of the printing and spacebar escapement mechanisms, because we will need these mechanisms in good working order in the latter part of this program. The tabulation mechanism on correspondence typewriters is essentially a manual mechanism, and because of this, its subdivision into input and output sections does not apply. As a result, here we provide you with a complete list of all the major adjustments of the tabulation mechanism. A number of these adjustments have already been discussed, or will be covered again in later segments of this series. Furthermore, the adjustments listed under numbers 8 and 9 are really 2 adjustments in one on machines of recent manufacture. Finally, there is one omission, the adjustment of the parallelism of the tab rack, which can only be done on later machines, as we discussed earlier. We suggest that you write down these adjustments, leaving a couple of lines between the entries so that you can take a few notes while we go through each one of them. Hopefully, you will remember them better that way. You are expected to carry out each of the adjustments as we complete their discussion. In a few instances, you will have to determine which level mechanism you have on your machine and then pick the appropriate specifications. Keep your adjustment manual at hand in case you wish to use it. Notice in the circular insert of the adjustment frame that one of the pieces is identified as the backspace pawl. This clearance between the backspace pawl and the escapement torque bar is hard to observe in the machine, and it is not conclusive. The drawback is that the backspace rack is not fixed front to rear. It sort of hangs in there, and it may actually change its front to rear position depending on whether the backspace pawl is engaged with it or not. This simply means that the backspace pawl is not fit to be used as a reference point for front-to-rear adjustments. In the lower frame, we have a picture of the escapement mechanism as seen from below the machine. When it is at rest, we know that the tip of the escapement pawl, indicated by the red pencil, is seated all the way into the dwell, or the vertex, between two teeth of the escapement rack. When the escapement pawl is in this position, bottomed out, so to speak, in the escapement rack, it is necessary that the tab lever lug, indicated by the yellow pencil, be allowed to come to its rest position in front of the step of the escapement pawl, into the condition depicted in the picture. If the stop lug for the tab lever is not formed properly, the tab lever may never have a chance to return to its rest position at the end of a tab operation. The operator will then be able to depress the tab key, but the escapement pawl cannot be pulled out of the escapement rack, and the result is no tabulation. Therefore, you are better off making your adjustment of the tab lever stop lug on the escapement bracket using the escapement pawl rest position as the fixed point, instead of the specified backspace pawl shown in the adjustment frame. We suggest that after the adjustment, you perform various tab operations and allow for a very slow return of the key lever while observing the restoring of the tab lever. You should be able to notice a very positive jump of the tab lever from left to right when it repositions itself in front of the step in the escapement pawl. This jump must occur before the tab key is fully restored. The rest position of the tabulation lever is the fundamental adjustment of the tab mechanism, and thus one of the most critical adjustments of the tabulation mechanism. We must learn how to check the clearance between the vertical lug of the tab lever and the escapement pawl from underneath the fully assembled machine, as shown in the lower left frame. The first secondary adjustment of this sequence was already made earlier, because we needed the parallelism of the tabulation torque bar in order to properly finish the adjustments of the escapement mechanism. As a result, we will not discuss it any further. The next adjustment is the angular positioning of the tabulation torque bar. The adjustment of the angular positioning of the tabulation torque bar is a non-critical adjustment for correspondence typewriters, since it merely requires that the torque bar be vertical on its edge, which makes it parallel to the tabulation trigger, indicated by the red pencil. The adjustment is made by changing the length of the tabulation torque bar link, shown in the upper left-hand insert. Check your machine for this condition before continuing. The angular position of the tabulation stop rack uses the tab set and clear control crank as a fixed point on the power frame, and the extreme right tab stop, which is fixed onto the tab rack, as the reference point on the tab rack. Through the clamp colored green in this adjustment frame, we can vary the position of the rack until it meets the specified conditions. We can now change the position of the tab racks, requiring different adjustment specifications. Compare your machine with these tolerances and make whatever corrections it needs. While you work with the tab rack, check the parallelism of the tabulation rack also. An easy method of checking the parallelism of the tab rack is to engage the tabulation lever at the extreme left side of the machine and then move the carrier to the extreme right side, observing all along the clearance between the tip of the tab lever pawl and the body of the tab rack. Once again, the parallelism of the tab rack is changed by altering the front-to-rear position of the tab rack support bracket, made out of black nylon in this example. In early machines, this adjustment is not possible because all torque bars are held by the same support bracket. The lateral position of the tabulation rack has to meet the requirements of the adjustment frame shown in the lower left insert, and the position of the rack can be altered by rotating the modified nut indicated by the yellow pencil. For single pitch machines, the tab lever pawl adjustment requires that the tab lever be at red line, and that the tab stop be set so that we can perform the adjustment. On dual pitch machines, the tab lever must be held in its engaged position by the tab lever latch. Dual pitch tab rack adjustments are covered in detail in program number 10.2. Check the clearance given in the figure on the left if you are working with a single pitch machine. This represents the fifth secondary adjustment of the tabulation mechanism. One of the most important adjustments to be made in connection with tabulation is the tab lever latch adjustment, because it controls the clearance between the escapement pawl and the escapement rack during tabulation. If the escapement pawl is held too far away from the rack, we will not get reliable tabulation. This is again an adjustment which has to be checked from the side of the machine. And whether you have a single pitch or a dual pitch machine, the requirement is that the escapement pawl should be held at a distance of 1/4 of 1 millimeter away from the escapement rack, once tabulation is engaged, and once the tab lever is held in position by the tab lever latch. The 7th and 8th secondary adjustments of the tabulation mechanism can be regarded as two adjustments with one objective, primarily as a result of the changes the mechanism has undergone since its inception. The length of the tabulation key lever link determines how far the tab lever is going to be rotated, right side towards the rear, during tabulation engagement. This simply means that unless your machine comes equipped with the old-style overthrow stop shown in the picture, we can treat the adjustments of the key lever link and the tabulation lever drive as one and the same adjustment. The specifications for the old-style overthrow stop are given in adjustment frame number 172 and the left side of frame 180. On early-level machines, failure to properly adjust the tab lever overthrow stop tends to cause premature disengagement of the tabulation, because when the operator engages tabulation, the tab lever pawl might be flung to the rear far enough to engage with the notches in the tab rack, and then act just as if the tab lever had encountered a set tab stop. It is a sound idea to test the tab lever overthrow adjustments very thoroughly, since it depends on how the operator depresses the key lever whether or not the tab lever tends to be thrown too far to the rear. And as if the agglomeration of adjustments at this spot weren't enough, we notice that on this machine, the overthrow stop plate for the tabulation lever doubles up as the velocity control cable deflector at the point indicated by the yellow pencil. This means that when we position the overthrow stop plate, we must adjust the overthrow stop clearance and the deflector shoe clearance at the same time. The deflector should be as close as possible to the frame of the machine, but never touch it as it travels along the full width of the typewriter. Before we leave the subject of the adjustment of the tabulation key lever link completely, we should mention that it is important not to allow the indicated point of the intermediate bridge to touch the base of the power frame when the tab key lever is restored. In order to avoid this, we must of course first adjust the key lever link, and then the tabulation torque bar link, which determines the angular position of the tab torque bar. Check your machine for this condition before continuing. We have already discussed the adjustment of the tab set and clear plate in Program 10. We are only repeating it now for the sake of completeness, since we had to take the plate out when we removed the escapement bracket. Of course, if your machine is a single pitch machine, only frame 186 applies. Be sure to also test the operation of the plate after you have locked it down by tightening the screw on the carrier. This constitutes secondary adjustment number 9, or the 10th entry in our sequence of adjustments for the tabulation mechanism. The tab set and clear overthrow stop adjustments are rather critical, particularly on single pitch machines. Excessive rotation of the tab stop rack during tab set operations may cause the tab lever pawl to miss the tab stop, and excessive top-to-front rotation of the tab rack during tab clear operations will cause the tab stop to interfere with the tab set finger, or lug, which is part of the escapement bracket. The position of this arm controls the position of the tab set and clear key through the link attached to the bottom of the arm. Once again, check your machine for these specifications. The tab set and clear key should be positioned so that the upper tips of the key top are aligned with the slope of the keyboard. All we have to do in order to achieve this is to shorten or lengthen the link, which connects the key to the tab set and clear arm. Now reconnect the ribbon lift control link spring to the lug of the escapement bracket. Next, install the velocity control cable deflector so that at the indicated point there is a minimum clearance, but also so that the deflector never touches the frame of the machine while traveling from one side of the machine to the other. Finally, put away your notes for the time being and use this adjustment list only to go through each one of the listed adjustments on your machine one more time. See whether you can explain them, and the correct procedure to make them, without the aid of your notes. There is no need to break the adjustments again and redo them unless you find that your machine is substantially off the specified tolerances. When you have completed the review assignment, we will move on to the mainspring and the cords. Before we reinstall the escapement shaft with its drums, take a close look at the escapement shaft bearings. Anytime you have disassembled the mechanism down to this point, this is the time to inspect and lubricate the bearings. When the machine is fully assembled, you will never be able to reach these bearings as easily as you can reach them now. The bearings are pressure fit into the openings in the frame at the front, yellow pencil, and in the main spring support plate at the rear, red pencil. If you should ever have to replace these bearings, when you reinstall the new ones, make sure that you tap only the outer rim of the bearings to avoid any possible damage to the races and the balls. Once you have lubricated the bearings, reinstall the escapement shaft with its drums and the compression spring if your machine comes equipped with one. It is most important that the carrier return drum be allowed to spin freely on the escapement shaft for the cord installation procedure, which we will show you later in this program. Make sure that there are no binds or burrs interfering with the movement of the carrier return drum on the escapement shaft. We have studied in the preceding programs of this series that when the escapement shaft is pushed all the way towards the front of the machine, the escapement cord drum should be positioned onto the shaft so that the indicated inside surface of the drum is flush with the end of the escapement shaft. We use that setting for the fundamental adjustment of the operational shaft adjustment series. Make sure that you place the escapement cord drum of your machine in this position also. After you have tightened the carrier return drum so as to hold the escapement shaft in its forward position, check the drum gear to pinion gear engagement, checking the carrier return pinion gear first, and then the tabulation governor gear on the right. Be sure not to create any binds for the pinion gears, otherwise you will end up piling letters. Now reinstall the mainspring, making sure that there is full engagement at the point indicated by the yellow pencil, and at all 4 points for the mainspring housing, of which one is indicated by the red pencil. In this program, we shall provide you with the option of loading the maximum tension into the mainspring using the power of the motor or the hand cycle wheel. We shall explain both methods simultaneously. The first method is called the power-on method, and the second is called the power-off method. Regardless of which method is ultimately used, it is imperative that the spring be securely held in its position. At this point, reinstall the on-off switch and connect it to the on-off key lever link. Then make sure that the switch is in the off position and plug the cord into a convenient power outlet. This, of course, is not necessary if you plan on using the power-off method. Now make sure that all of the tab stops are fully restored so that the carrier can tabulate from the extreme left position to the extreme right position without stopping. The stops should all be in the position indicated here. Finally, hand cycle the machine for a few turns to establish that none of the mechanisms is partially engaged and that the motor can operate freely. Now reinstall the motor, then turn the motor on. Then depress the carrier return key and let the motor run or turn the hand cycle wheel until the torque limiter begins to slip. This is an indication that the mainspring has been fully loaded and that now we can turn the motor off again. Notice that the carrier return shoe closed the carrier return clutch, but that the operational shaft movement is not being transmitted to the escapement drum since it has already been stopped. Once the torque limiter is slipping, turn off the motor. From now on, as you work on the machine, if you're using the power-on method, be sure to keep in mind that the machine is plugged in and that you have to stay away from the on-off switch, except for the times when you deliberately want to turn it on. Now find a mark on the escapement drum, such as the anchor spot for the escapement cord, the red pencil in the lower left corner, and then depress the tab key. You will find that the mainspring tension still will not be released, in spite of the fact that when you depress the tab key, the carrier return override feature disengaged the carrier return clutch. Now, the indicated tab governor spring has simply taken over the job of holding the spring tension in the mainspring. Manually turn the operational shaft, top towards the front, until the escapement cord drum has had a chance to turn by a couple of turns, and until the anchor spot for the escapement cord points upward again. At this point, find the escapement cord with the indicated offset terminal lug. Make sure that the indicated knot is held towards the rear of the machine, as shown, and then reconnect it to the carrier. Afterwards, notice how the cord should be threaded and then laid into the machine. You might wish to use a pair of tweezers, or the forked end of the IBM spring hook and a screwdriver, to insert the other end of the escapement cord into the cavity, or hollow, of the escapement drum. Do not hook the lug directly onto the drum. Rather, make it a point to cause the lug and the knot to disappear inside the escapement drum. Take advantage of the fact that the metal lug at this end of the cord is slightly curved in order to facilitate the engagement. Now, while holding the cord in the manner shown, preferably even using the IBM spring hook, gently turn the hand cycle wheel, top to the front, and allow the escapement cord to wind up around the escapement drum. Once the slack of the escapement cord is all gone, reinstall the idler gear pulley and place the escapement cord on it, as shown. Since earlier in this reassembly process we depressed the tab bar, once the slack of the escapement cord is taken up, as we continue turning the operational shaft, the carrier starts to come towards the right. Let the carrier move towards the right until it is, once again, positioned over the carrier return clutch. Now take the straight end of the carrier return cord and hold it under the indicated velocity control cable. Then, with one hand, hold the carrier return cord in this position, and with the other hand, tilt the machine onto its back. Using the spring hook, pull the end of the cord out from underneath the machine until you have about 5 centimeters of it hanging out at the bottom of the machine. Use the forked end of the idler spring hook again in order to hold the tip of the cord, and then reconnect the carrier return cord to the carrier. As soon as the cord is hooked up properly, as shown by the insert, you should hold it taut in order to prevent it from falling out again. Finally, place the machine onto its feet again, but be careful not to operate the on-off switch inadvertently while handling the machine. The motor must stay turned off for the time being. Carefully lay out the carrier return cord so that you can afford to release the end of the carrier return cord, which is connected to the carrier, without it becoming unhooked from underneath the carrier. Then thread the cord between the lower portion of the rotate tape and the upper portion of the rotate tape towards the rear of the machine. Make a special effort not to let the cord fall into the grease of the pulley bearings while you do all this. As you pull out the carrier return cord at the rear of the machine, you must also see to it that it passes in front and to the right of the tabulation torque bar link. To improve visibility, we have temporarily removed the motor from this demonstration machine. In order to use the power-on method, simply leave your motor in the machine and lay the cord over the top of it while you perform the following steps. Once the loose end of the carrier return cord is pulled out at the rear of the machine, connect the forked end of the spring hook just behind the curved terminal of the cord. Then lay the tool and the cord down for the moment. Next, use the carrier return cord as shown to pull the carrier towards the right of the machine until the anchor spot on the carrier return drum is in a convenient position for the reconnection of the cord. It goes without saying that if the position of the carrier return drum on your machine happens to be convenient to begin with, there's no need to pull the carrier towards the right as shown here. Finally, reconnect the carrier return cord by tucking the metallic terminal into the hollow inside the carrier return drum. To complete the job of reconnecting the carrier return cord to the carrier return drum, we must make certain that the terminal is completely tucked away inside the carrier return drum, and that it will not be able to inadvertently rub against the indicated surface of the power frame. However, before you tilt the machine onto its back in order to investigate this condition, make certain that the end of this cord connected under the carrier does not become disconnected. Also, again, be careful not to turn on the on-off switch by mistake. After you have inspected the carrier return cord engagement with the drum, turn the machine on its feet again and then reinstall the carrier return cord idler pulley. Place the cord over the pulley, as shown in the lower left frame, before we take up the slack from the cord. Now pull all of the slack in the carrier return cord towards the front of the machine, taking great care not to get the cords all greased up and dirty. While using one hand to hold the rear portion of the carrier return cord taut, use the other to pull the carrier towards the left side of the machine, as shown. In order to accomplish this, you will of course have to let out cord from the one hand which holds the rear portion of the cord. Notice that as a result of this action, we ended up with 1 or 2 turns of carrier return cord wound nicely around the carrier return drum. We're going to need that condition in just a moment. The following explanations apply to right-handed persons. In order to at least partially make up for the omission of a description prepared specifically for left-handed persons, the explanations have been made as thorough and as detailed as possible, even at the risk of becoming too elementary or redundant. If you are left-handed, we respectfully ask to be allowed to rely on your skills in making the necessary alterations and compensations. Depending upon how far you have to move the carrier in order to position the carrier return drum into a convenient position, you will now have to contend with more or less slack in the carrier return cord. If you have just a small amount of slack in the cord, use this technique and your left hand in order to take it up. Notice that this leaves your left thumb free, and that you can slide your hand sideways without ever having to let the cord develop slack. If the cord slack on your machine is substantial, use this grip in order to keep it from allowing disengagement of the cord. Once again, the thumb is free, and, as it turns out, in a very convenient position for us to pull the carrier all the way towards the left side of the machine without ever letting any slack build up in the carrier return cord. Whichever grip you used, from now on and throughout the next few steps, keep your left hand on the carrier return cord, using only the right hand to carry out the various assignments. The additional leftward movement of the carrier will, of course, produce an additional amount of carrier return cord winding onto the carrier return drum. No matter which level of carrier return mechanism you have on your machine, while you hold the carrier with your left thumb so that it cannot move towards the right, hand cycle the operational shaft, top towards the front, to make certain that the carrier return mechanism has not been tripped inadvertently. Hand cycling of the operational shaft will of course produce carrier return engagement should the function have been tripped. In this case, complete the carrier return engagement until you obtain the depicted condition, and then manually disengage it by pulling the latch towards the front of the machine. During all this, keep your left hand on that carrier return cord. First, we must tilt the machine onto its back again, then we depress the space bar once, and then turn on the motor. All of this is to be done while holding the slack out of the carrier return cord with the left hand. If you should happen to be concerned about getting your fingers tangled up with the carrier return cord while the motor might try to pull on it, rest assured that the motor can only pull as hard as the torque limiter allows it. The moment you offer sufficient resistance to the pull on the carrier return cord, the torque limiter will begin to slip, and that will be the maximum pull which the motor can apply to the carrier return cord. Go ahead then. Turn the machine onto its back, depress the space bar, and then turn on the motor. Your having depressed the space bar once should have caused the disengagement of the tabulation mechanism, should it still have been engaged after all we've done so far. This means that now you should no longer need to hold the carrier with your thumb, since the escapement pawl should have taken over the job. Therefore, turning on the motor should have no effect on the carrier position at this point. Although we are asking you to turn on the motor in step number 3, the whole procedure can also be carried out manually. Because the right hand is free to turn the hand cycle wheel anytime, we need the top-to-front rotation of the operational shaft. Assuming that on your machine the power is on, you should now depress the space bar and let the carrier move towards the right side of the machine until you can reach the carrier return drum set screws. It was during this rightward movement of the carrier that we needed those carrier return cord turns around the carrier return drum. If we did not have them, we would have found that the cord would have come out of engagement with the drum as soon as we started spacing the carrier towards the right. Now loosen the carrier return drum set screws using the IBM double end socket wrench. But be sure to leave the socket wrench on the last screw which you loosened, and allow it to come to rest against the right edge of the opening in the base of the machine. If you decided to try the power-off method of cord installation, instead of the repeat spacebar operations, you should simply depress the tab key once, then turn the hand cycle wheel until the desired set screw becomes accessible. Let us now analyze this situation. Your pull on the rear portion of the carrier return cord is responsible for keeping the socket wrench against the right edge of the opening in the base of the machine. As a matter of fact, the wrench is now keeping the whole carrier return drum in a fixed position, while the escapement shaft is loose, or free to turn, as soon as the indicated escapement drum is allowed to turn. This does not yet happen, because the escapement pawl is holding the carrier. If you are doing the power off cord installation, instead of the escapement pawl, it is the indicated drum gears in engagement with the tab governor clutch, which prevent the escapement shaft from letting out the mainspring tension. At this point, having the carrier return drum held by the socket wrench, we must allow the escapement drum to turn, while at the same time we gradually let out the front end, or the carrier end, of the carrier return cord. Ideally, you should let your left hand travel with the carrier. Before you attempt these steps yourself, listen to the complete explanation through the next slide first, and then review the explanation if necessary. For the power off method, we must turn the operational shaft top to the front, as demonstrated here, and let out the carrier return cord as the carrier moves towards the right of the machine. For the power on method, we simply depress the space bar all the way down and let the carrier travel to the right side of the machine until eventually the slack is all gone. It happens often that the carrier gets to the extreme right side of the machine without having taken out all of the slack which was in the carrier return cord. All you have to do is temporarily tighten the one set screw which is being held by the socket wrench. Pull out the socket wrench, and then with your left thumb pull the carrier towards the right until the tightened set screw on the carrier return drum reaches a position from which it can be reached once again. Then loosen the set screw again, leaving the socket wrench on the set screw as done before. Finally, continue with the repeat spacebar operations if you're using the power on method, or resume turning of the operational shaft if you're using the power off method. As soon as all the slack of the carrier return cord is gone, you regain the use of the left hand, which was keeping the slack out of the cord. None of this is going to work quite right unless the escapement shaft is allowed to spin freely inside the carrier return drum when the set screws are backed out. Whenever you have a bind, you may have to help the turning of the escapement shaft, and this can become a back-and-forth struggle for the right hand, since the left hand is still busy holding the slack out of the carrier return cord. At this point, you should go ahead and let the carrier move, either by repeat spacebar operations for the power on method, or by tab key depression and turning of the operational shaft for the power off method. If you're still in doubt, review this sequence again from the loosening of the set screws. This procedure will require a bit of practice. If you fail in your first attempt, simply review the procedure and try it again. Once you have learned it, however, you're not likely to forget it anymore. There isn't anything complicated about it, it just requires the development of the skill. Please note that at the end of step number 4, the socket wrench is still holding the carrier return cord drum. Remove the slack of the carrier return cord from your machine at this point. Finally, if the motor is on, press in on the cord tension pulley, as demonstrated here by the right hand. Without the motor, you will have to simply turn the operational shaft top to front while pressing the tension pulley towards the left. You should find that the tension pulley will not be able to come back out after you release it, provided the escapement shaft was allowed to turn when you turned the operational shaft. Pressing in on the tension pulley amounts to the same thing as creating slack for the escapement cord. If at that time the escapement drum is allowed to turn, it simply takes up all the slack it gets, and the result is that the tension pulley applies its spring tension to the cord system. Now, with one hand, hold the escapement shaft pushed all the way toward the front of the machine, and with the other, tighten the set screws for the carrier return drum. Check the indicated engagement between the escapement drum and the carrier return and tab governor pinions one more time before you start the final testing. Now move the carrier back and forth a few times by alternating carrier return and tabulation operations, and then check the position of the tension pulley. Ideally, the edge of the pulley support slide should be aligned with the mark. If the tension pulley comes to rest slightly to the left of the indicated mark on the support bracket, consider this okay. But if it is toward the right of the mark, you need to remove some more slack from the cords. If your machine does not have such a mark, measure the distance from the pulley to the side frame. It should not exceed 0.5 centimeter when the mechanism is at rest. To correct small differences between what you have and what you want in the cord system, here is an easy way. First, turn off the machine, preferably also unplug it. Then disconnect the escapement cord from the carrier so you can twist it by a few turns before reconnecting it. If you turn it in the same direction as the turns already in it, you will shorten the cord. If you turn it so as to unwind its twists, you will lengthen it. This process is acceptable only for small increments. The best alternative is to loosen the set screws of the carrier return drum once again, and then push in the tension pulley while turning the operational shaft, so that the escapement shaft and drum can take up the excess slack. One final recommendation: beyond understanding how the cord installation is done, practice will make you efficient and fast at it. The whole process can be carried out in 5 minutes. We suggest you do it a few times until you feel you can do it comfortably. Speed will come with practice. Now use the spacebar in repeat mode to allow the carrier to escape toward the right margin stop. But instead of letting it move all the way to the right, hold the spring gauge against it in the manner shown. The reading on the scale should come to approximately 250 grams or 1/4 kilogram. If a correction is needed, go to the mainspring at the rear of the machine. Unhook the spring housing from the mainspring support plate so you can give or take the necessary turns by applying the turning action directly to the housing of the mainspring. This is a rather dangerous procedure because you are dealing with a strong spring. When you work on the spring directly, always make sure that before one hand lets go of the spring housing, the other one already has a firm hold of it. All we have to do now is reinstall the card holder, the platen, the feed rolls, and the ribbon, and then perform an extensive functional test on the negative power system. The card holder should be aligned so that a series of V's have their vertexes lined up with the pitch lines on the card holder. The front-to-rear placement of the card holder should produce a space of only 1/4 millimeter between the platen and the card holder when the multiple copy control lever is in position A after you have performed an extensive test on the negative power system of the typewriter. Check the position of the tension pulley once again. After a good cleaning and a prolonged time in the parts box, the nylon cords have a tendency to stretch a bit right after they have been reinstalled in the machine. 1 or 2 readjustments is usually all they need before the length remains fixed. On level 2 Selectric II typewriters, we can use the same procedure of cord and cable installation, which we've used for single-pitch typewriters. We simply have to deal with a carrier return cable rather than a carrier return cord. The exception applies to the level 1 or very first dual-pitch typewriters that were produced. That system is also used by the present Remington single-element machines. It is characterized by the fact that it employs a tab escapement cable rather than a tab escapement cord. The main difference between the two cable systems is that the level 1 carrier return backspace cable drum can, to a limited extent, rotate on the escapement shaft, and that the tension spring is located to the rear of the backspace ratchet, between the carrier return backspace cable drum and the tension arm fastened to the escapement shaft. Understandably, it should not come as a surprise that the installation and adjustment procedures for this system might be slightly different. We can summarize the installation procedure with this list of steps. It is assumed that we start out with all of the components on the escapement shaft loose. First, we connect the carrier return cable to the carrier and thread it toward the carrier return backspace cable drum. Second, we connect the cable to the carrier return drum and manually turn the drum until all the slack is gone, and until the carrier is placed all the way toward the left side of the machine. To do this, the carrier return drum must be allowed to turn freely on the escapement shaft, and we hold the drum and the cable taut until we have completed step 3, the engagement of the backspace pawl, or driver, with the backspace ratchet. Step 4, we turn the escapement shaft all the way to the left, allow for minimum end play of the shaft by pushing it all the way toward the front, and then tighten the carrier return backspace drum assembly, set screw. The drum itself will still be able to rotate a limited amount with respect to the escapement shaft. We will need this ability in order to allow the tension spring to work properly. The half-cycled backspace mechanism will hold the carrier return cable taut while we turn our attention to the tab escapement cable. Step 5, we connect the tab escapement cable to the carrier. Then in step 6, having loosened the escapement cable drum, we manually wind up all of the slack in the escapement cable. Next, we slide the drum into engagement with the carrier return clutch pinion and the tab governor pinion, and then tighten its set screw. Step 7, the final step, is to manually load the by now famous 5 or 7 turns of the mainspring, with the carrier all the way at the right side of the machine. The cable tension on level 1 Selectric II typewriters is adjusted by giving the tension spring the correct amount of stretch after it has been installed into the cable system. We can meet the called-out specification by properly positioning the adjustable right-hand cable pulley. Here again is a little memory jogger, with questions aimed at establishing how well you have been able to comprehend and assimilate the material covered in this presentation. In the final analysis, however, the condition of the machine on which you worked should be regarded as the true test of your ability. We suggest that you perform one more thorough test, and also that you review the points which have given you difficulty. You should do this before you answer the questions, and before you go on to the next program of this series, Program 10.2. Thank you for the attention and time you have devoted to this program.